The most important thing I've learned in my entire career is that you cannot make a computer go faster. Well, except in the early 90s when computers had turbo buttons and you just press the button. But that's over. Now we are stuck with only one way to make software go faster, and that is to make the program do the same task with less effort. That's it. That's actually my only pearl of wisdom. But anyway. But truthfully, it's also the secret to becoming a more productive developer. Do less. Focus on the things that get you to your goal and make choices that get you there faster. Everything else is just a waste of energy. Everything else is what leads to burnout. So in that spirit, I want to talk about unit testing, because I honestly think unit testing is like a chainsaw. If you handle it right, you can save yourself tons of work, tons of time. But if you don't, ouch. So I'll try to explain why and give you an introduction to XUnit, AutoFixture, and Mock. And I'll walk through an example to try to point out how you can leverage those tools effectively to make your development process faster by doing less. As always, please subscribe to my channel and leave comments with your thoughts and your ideas. I'd love to hear from you. And if you're interested in seeing how spans can boost the performance of your Dapper repositories, visit my blog, Better with Code, and sign up for email notifications. Just check the box labeled Aggregate Mapper so I know that's the thing that you're interested in. Now back to the main event. I'm sure many of you are new to unit testing, so let's briefly talk about some of the benefits of unit testing. I think the biggest benefit is that it gives you confidence. The confidence that the change you made won't break existing functionality. The alternative is that you make a change and you manually test it, but that can take a long time, and so I don't recommend it. Another reason is that it improves the design of your code because it pushes you to decouple dependencies. That makes your code easier to maintain and change over time. Tests also make you think about the problem that your code is actually trying to solve. When you write code, you're always thinking about how do I make this work? When you write unit tests, you're thinking about how will it break? It's a different mental perspective that will improve the quality, the durability of your code. There are costs to using unit testing. Anytime you add code to your code base, you're assuming the responsibility of maintaining it. And whenever there's a code change, a refactoring, you might also need to refactor the unit test, and it can take time to run those tests while you're working, and it takes time on the build server if you're using a continuous integration process. If you have a test that fails when it should not, you have to stop and pause and deal with it. Figure out what caused the false alarm, and it takes time to understand why a test failed. None of those things sound like doing less to me, which is why it's so important to utilize the techniques that reduce those costs. And it can be done. Take a look at this graph. It has no actual data points and it's completely made up. But after years of using unit testing, I think it's basically true. We've got progress on the x-axis and effort on the y. The first line to consider is the blue one. That's what development is like without unit test. And at the beginning of a brand spanking new project, the code, it flows like hot maple syrup on flapjacks. Then as the months wear on, people spend more time on regression testing. They're making sure that they don't break something that already works. And the progress, it just slows. The next line to consider is the red line. It's the chainsaw that you don't use properly. It represents what happens if you have bad unit tests that suffer from the problems that I mentioned earlier, tests that have to be refactored when there's a code change, false alarms and such. Initially, you have to do more, and it sort of helps, but you put in a whole lot of effort to maintain those tests. The ideal choice is to have unit tests that let you do less. Tests that check for the outcome of a function and not the implementation, so you spend less time refactoring them. Tests that free you from manually testing things that require data setup. Tests that point you to the bug that you introduced, so you spend less time trying to figure out what went wrong. A set of good unit tests leads you to sustainable growth of features and productivity. All right, I'm going to get off the soapbox. Let's take a look at some real practical examples of how you can utilize unit testing of a domain entity. To start off with, let's take a quick tour of a domain entity that we can write unit tests for. Here's a customer class that could be used to keep track of a customer onboarding process. And we've got some properties like name, date of birth, and as well as a status. And there's a handful of functions that we can use to mutate the state of the object, like assign salesperson and record a credit. The goal is to write unit tests that test the behavior of this object, but not the implementation. So let's add a test class and give it a go. So one of the first things we need to do is add some NuGet packages to our test project. For today, we'll be using XUnit, so we need to add the NuGet package for XUnit as well as xunit.runner.visual studio, so we can go ahead and run our test within the Test Explorer in Visual Studio. We'll also add AutoFixture and mock, and we'll cover those a little bit farther down the line. With that taken care of, let's take a look at a unit test. In the case of XUnit, any initialization that needs to be done is performed in the test class's constructor. Any corresponding teardown of objects is performed in the dispose method, so our test needs to implement iDisposable. Now, how you name your test is important because you want to be able to read the names of the failed test and understand what went wrong. I like to use the combination of method name, expected behavior, and state under test to describe what's being tested. But there's other conventions, and you can choose whatever works for you. Now, typically, unit tests follow a pattern of performing 3 steps: an arrange, an act, and assert. An arrange sets up the conditions needed to perform that test, while act is the action that you're testing. An assert checks to verify that the action performed as expected. Now, another common term that's used is SUT, system under test. It's the thing that's being tested. Here's a test function that's intended to call the constructor of the customer class and verify that the isDeceased property is set to false. So in this case, the arrange and the act portion of the test consist of creating a new customer object named SUT. I'm calling the assert.false method to verify that the isDeceased method is false. Now notice that I put the attribute fact on the method so that it'll be identified as a test method. Now this is a pretty straightforward example, but the next example is a little bit more interesting because I'm using AutoFixture. Now the purpose of this library is to simplify and reduce the work you need to do in the arrange portion of your test. And it can randomly create values or populate objects. And in this example, I'm creating a random string that I can pass into the update name method. All right, so let's go ahead and run this test and see how well it works. I can go ahead and right click and choose run test, or here I have the Test Explorer. I can go ahead and select that test and click run, and that will go ahead and execute it and let me know that it did successfully pass. All right, now these tests are all well and good, but let's look at something a little more complicated. Let's look at the record credit check test. Now, in order to test this function, the customer needs to have a name. So I'm using the update name function as part of the arrange portion of the test. This is actually not a very good thing. The problem with this test is I'm actually testing 2 functions, and I want this test to have one purpose: test the record credit check method. And if I made a breaking change to the update method, this test could fail. It shouldn't, but it would be a false positive test, and I don't want false positive tests. I don't want to waste time chasing down false positives, which means I need a better strategy for unit testing my domain entity. To solve the problem, I'm going to leverage a tool called mock. It creates a simulated object that mimics the behavior of the real one. In fact, I'm going to mock the customer entity that I'm testing, but I'm going to tell the mocked object to call the real class's record credit check function when I test it. So let's look at the test, and then I'll go back and explain how it was accomplished. In the constructor of my unit test, I'm going to declare that I want the base class, the customer class, to be called when functions are executed. And then I'm going to specify that the name property will always return a string using AutoFixture's create method. That's the setup that I want to have for all the tests that I perform in this test class. Now, when I run my test, I can call the SUT, the system under test, and execute the record credit check function, and then I can assert that the customer status ID has changed to credit checked. So let's step through the code so you can see what happens. I've put a stop on the call to the record credit check function so we can step into it and make sure it is set up the way we are expecting it to be. Right click and choose debug. And here we go. Now I can go ahead and step into the function. You can see that we are actually hitting the customer entities function, not a mocked function. And if I mouse over the name, you can see that AutoFixture has randomly assigned a string to it. So if I let it continue on, we now have a passed test. How do we accomplish this? Well, here I have my test class, and it's inheriting from an abstract class called UnitTest, which takes in a generic parameter, and that is the type for our system under test. Let's switch over here to that abstract class so you can take a look and see how it's operating. There's a couple things that I like to do with these, and one is to formally define a property called SUT, and that is of the type that we are going to be testing. I also like to set up a fixture, and that fixture is AutoFixture's static class to go ahead and do the arrangement for my unit test. Just makes it nice and easy because it's always there. The more important thing to the test we just looked at is the call base when mock method. It allows us to pass in a true or false value to set the behavior of the mock object. So it's just going to go ahead and check to make sure that the system under test is of type mock, and that we can go ahead and that it has a value so that we can go ahead and set the call base value. The other thing I like to have here is a property to define the arguments that I need to create a new instance of the system under test. So I just have a property here so I can go ahead and set those ahead of time. And then whenever I go ahead and new up a new instance of the test, the SUT automatically gets created with those constructor arguments. That is a super cursory introduction to AutoFixture and mock. There's so much more to learn about fixturing and mocking, but I found them to be absolutely critical to creating unit tests that minimize the cost of maintaining them. Software development is hard. It's a learned skill, and if you understand the tools at your disposal, you can put in less effort to your work and get great productivity. I'm actually considering showing everyone how I test my Dapper repositories, which is a little bit trickier, but definitely worthwhile. So put a comment down below if you're interested in finding out how I do that. All right, everybody, have a great day.